So that we don't get caught up in vocabulary, I'm going to go over what a few vocabulary words are. What we did last time and what we just reviewed in the warm-up were Taylor and Maclaurin polynomials. So you went out to a certain degree. Usually the third, fourth, or fifth is about what they ask you to do. What we're going to do are power series, which means if you were to take what we just did, but make it go on for literally ever. Do you get what I'm saying? Like infinitely. So to the infinite degree. Instead of approximating a function, it will be the function. It will be perfect. Do you get what I'm saying? Like we can make it go forever. It'll actually be perfect. That is what a power series is. I'm going to do a little Venn diagram here. So you have power series, which is just a general term for saying we have this infinite series that represents a function. If you can make it go forever, it is the function perfectly. It's not an approximation anymore. Power series, it's a series that represents a function. Inside of that, you have Taylor series, which specifically have this pattern that we use. So again, power series is a general term for an infinite series. Taylor series specifically has this pattern that we went over, and within Taylor series is Maclaurin, which means it's centered at 0. Okay, so that's just kind of, don't get caught up with the words though. But that is what they mean, just to throw that out there, right? So what I want us to do, and I'm going to pause the video. We're all going to do this, and then we're going to do a I got this, what did you get kind of thing. I want you to find the first 5 derivatives. I want you to go all the way out to the 5th one for sine of x. I'm going to hit pause, and I want us all to just do that, and then we'll check we all got the same thing. Should go, if you're watching this, time jumped for you. Cosine, negative sine, good so far? Or do you agree with me? Negative cosine, sine, cosine. Well, because guess what? I'm a human being and I mess stuff up too. So that's, again, why I like to check, because, if I mess something up, then you can help me out. All right, so we're going to write the Maclaurin series for sine of x. It's exactly what we did in the warm-up. We're just going to put a ... and make it go on for literally ever, okay? Maclaurin means we're going to plug in 0. Okay, so for the first one, sine of 0 is 0. Good. Oh, you don't need to be sorry. Over 0 factorial x to the nothing. We're going to write it all out because it is very pattern driven. And if you leave out part of the pattern, you're not going to be able to see what's happening. All right. Plus, now we're going to use our first derivative that we've got over here. Cosine of 0 is 1. Good. So 1 over 1 factorial x to the 1. Plus, now we're on our second derivative. Sine of 0 is 0. It doesn't really matter that it's negative. You can't really negative a 0. So it'll look like that. And then your third derivative, cosine of 0, 1, but it's going to be good. So negative 1 over 3 factorial x to the third. Fourth one is going to be, I did this on purpose so that you could hopefully notice the pattern. And then fifth derivative, cosine of 0 is 1. Plus ... Again, we want it to go on forever and ever and ever. Now we're going to do 2 things. We're going to clean that up, and we're going to write the general term. Often what it says, often, almost all of the time, what it says on the AP exam is write the first 4 non-zero terms. And do you get why they say non-zero? They don't want those ones. The first 4 non-zero terms and the general term is how the directions usually go. This one's going to go away. This one's going to go away. This one's going to go away. Those ones are all 0. We're going to just clean it up. So this one would just be, x minus, and usually you see it written as x to the third over 3 factorial. They'll combine it together to be a single fraction. Plus, and then this one would be x to the 5th over 5 factorial. And I want to see if you can give me the next one, and then we'll try and write the general term. The next one would be minus x. Good. Cool. It's not that hard, right? But you have to do a bunch of them in order to generate the pattern. Now put plus ... plus, and we're going to write the general term. This is 0, this is 1, this is 2, this is 3. The first term is actually the 0th term where n is 0. Do you know when you have that sigma at the bottom, it says n equals 0? It's like, okay, thank you for heads nodding. I know it's our first day back. Thank you for bearing with me. All right. So I would do the alternating part first. It's going to be -1 to the n. That's what's going to cause it to alternate. If you plug in 0, it's going to turn positive. If you plug in 1, it's going to turn negative. Do you get what I'm saying? It's going to make it be every other one, okay? Now it's going to be x to the power of what? I want you to just take a minute and think about it. If you plug in 0, you should get a power of 1. If you plug in 1, you should get 3. If you plug in 2, you should get 5. And if you plug in 3, you should get 7. Think about it. It's not like a fast thing if you're not used to it. It's going to be 2n plus 1. Good. Nice. Over 2n plus 1 factorial. It's the same number, so we already did it. So that's your general term. Again, that's how the directions go. Right? The first 4 non-zero terms and the general term. Now what we're going to do is transform them. It says find the Maclaurin series for sine of not just x, but x squared. Everywhere you see an x, you're going to replace it with x squared. And don't simplify too much or you won't be able to figure out what the general term is. You want to not simplify or you're not going to be able to write this, okay? So if I replace x with x squared, that first term is just going to be x squared. All right, minus x squared to the third would be x to the 6th. The 3 factorial is not going to change. Plus, this would be x squared to the 5th. So x to the 10th. Good job. And then minus would be x squared to the 7th. So x to the 14th over 7 factorial. Now, if you figure this out really fast, please don't shout it because I want to give everyone a chance to think about it. The -1 to the n is not going to change. This is, and I always write this. I kind of can't figure it out without writing 0, 1, 2, 3. I sort of have to do that. If you don't need to do that, that's fine. That's not a requirement at all. That part's not going to change because it's still alternating. And the 2n plus 1 factorial is not going to change because we didn't alter that. The only thing that's going to be different is x to the power of whatever. I just give everyone a chance to think about it. Now, if it seems like a lot of time went by and you figured it out, then maybe, you can share with the group, but give everyone a chance. Or just murmur quietly with the person next to you and see if you can. I just want everyone to get a chance to think.
That would make sense.
So if you plug in 0, you should get 2. If you plug in 1, you should get 6. If you plug in 2, you should get 10. And if you plug in 3, you should get 14. Does anyone have an idea? It is going to be 4n and then plus 2. Good job. I think that's hard, to be honest. It's not super easy. And you can do that too. But if you weren't asked for this and you didn't have it written right there in front of you, you might not think, did you know what I'm saying? Because on the AP exam, they're not going to lead you through it step by step like I did. They're just going to throw you in the deep end. All right, we're going to try it again. I'm going to pause. I want you to find your first 5 derivatives. I know you love me right now. For cosine. We'll do a couple more and I'll give you a little brain break. But I'm going to pause this. You have to do enough of them to see what the pattern is. If you only do 1 or 2, you don't get what the pattern is. So you have to do a bunch of them. So go ahead and do the first 5. And we'll make sure we all got the same. So negative sign, negative cosine, positive cosine, negative sign. Cool. All right, buckle up. Maclaurin means we're going to plug in 0. So we're starting with the original function. Cosine of 0 is 1. So 1 over 0 factorial x to the 0. All right, first derivative. Sine of 0, 0. I know it's tempting to just write 0 and forget the rest of it and move on. It is very pattern driven. I strongly suggest you write all of it. I'm not going to have an argument with you over it if you're like, no, I'm just going to write 0. But all right, second derivative is going to give us -1, good job. Over 2 factorial x to the second. Third derivative is 0. Fourth derivative is 1. And then fifth derivative, bless you, is 0. So we're going to do two things. We're going to clean it up, and we're going to write the general term, which again, I think is the hardest part. So I'm going to scratch out the ones that go to 0. That would be this one, and this one, and this one. So what does this entire first term simplify down to? 1. The whole thing is just 1. X to the 0 is 1. 0 factorial is also 1, not 0, and then 1, right? So the next one is minus x squared over 2 factorial, and then plus x to the 4th over 4 factorial. And I want to see if you can give me the next one. We had to do enough of it to see what the pattern is, though. Again, if you only do 1 or 2 terms, you really can't see it, right? The next one's going to be negative, and then 6 over 6 factorial. Lovely. I'm going to write my 0, 1, 2, 3. Again, if you can do it in your head without that, that's awesome. I'm just not one of those people. And we're going to write out our general term. First, to make it alternate, what are we going to put? Yep, -1 to the n. And then it would be x to what power? This one's a little easier, I think, than the other one we did. 2n. You're just doubling it, right? And then so down here is 2n factorial. Sweet. Now we're going to do a transformation. Everywhere you see an x, you're going to replace it with square root of x, which is x to the 1/2, if you want to think of you're halving everything. Now, 1 is not going to change because there's not an x there for you to plug anything into. All right, so then it'll be minus, perfect, x over 2 factorial. And if you want to put a 1 there, you can, because we're going to have to write the general term. If that helps you, you can do that. All right, plus, you're plugging in a square root of x, or an x to the 1/2, if you will. So it'll be x, perfect, over, but yeah, that part doesn't change. And then minus x to the 3rd over 6 factorial. So for your general term, again, the alternating part doesn't change, and the factorial part doesn't change. So those, you can just go ahead and write that to begin with. The only thing that changed was the exponent on the x. And it's literally just n. Again, that's why I write 0, 1, 2, 3 at the bottom, because that helps me. All right, so we did enough of them a long way. Here's your little cheat sheet. You don't get this on the AP exam, obviously, so you can't use it for my test either. Now, you can do whatever you want with this. You can burn it or throw it away if you want. But I will tell you, me personally, I have memorized sine, cosine, and e. And I strongly recommend that you memorize at least those 3 if you want to put a star next to them. Now, if you want to go and memorize all of them, that you can. Those ones are less likely to show up, though. And the ones I'm going to put on my test are sine, cosine, and e. Is everybody cool there? Okay. Now, the way I remember them, e has every single term. Do you see how none are missing? And it doesn't alternate? Why does that happen? Yeah, what's the derivative of e? E. And then the second derivative is e, and the third derivative, e to the x. They're all e to the x, so you get them all. Sine, what do you notice about sine? The odd ones, and it alternates. Sine is an odd function. You may have not learned that in pre-calc, but it is, right? And cosine is an even function, and they alternate. Those are the 3 I have memorized. Cool? All right, we'll do a couple more, and I'll give you a little brain break. So given this, we want to find an expression for f of x. What I want you to do is look at what we just talked about. Is it sine, cosine, or e, what this looks like? Why sine? Oh, well, that's clever. I don't usually, the general term freaks me out a little bit, to be honest, but that's cool if your brain, we all think differently, and that's neat. I would go, hey, they're odd. and they alternate. All right. So it is sine. What happened to it? Sorry, I didn't mean to put a parenthesis there. Because it's not the exact same as sine x. We did a transformation to it. It's slightly different. What happened? Yeah, so, somebody said it. We multiplied it by, well, x to the 2, x squared. So it's sine of x times x squared is what we did. We took the sine of x power series and we multiplied every term by an x squared is what we did there. Yep. We'll do like 2 more and I'll give you a brain break. All right. So for this one, if you have E memorized, you do not need to find all of your derivatives. And for right now, we'll just use this. Okay. Everywhere there is an x, you want to replace it with 4x. Okay. Now I can't have both of these things. Well, maybe I can. I'll fold my paper. I was going to say I can't have both of these under the projector at the same time, but I'm going to give it a shot. All right. So here's e to the x. Everywhere that there is an x, we're going to replace it with a 4x. So your first term is just going to be 1 plus what? 4x, good. Plus 4x quantity squared over 2 factorial. Again, the less you simplify, the easier it is to write the general term. Plus, and then what would the next one be? 4x cubed, good, over 3 factorial. Now it said to write the first 4 non-zero terms and the general term. So I want us to all try to think about it and see what we can come up with. Does it alternate? No. And if you want to write out your 0, 1, 2, 3, I kind of didn't leave myself enough room. The denominator is just going to be, n, right? N factorial. That's why I write out the 0, 1, 2, 3. That helps me to see that. And then the numerator would be 4x to the n, right? That's all that is, right? Yeah, cool. Let's do one more, then we'll take a little break. So this one, you're going to take your e to the x power series, and you're going to multiply every term by x. Cool. So you're basically just distributing an x into this. So it'll be x plus x squared, good, plus x cubed over 2 factorial. I hate when it doesn't match like that. That bothers me so much. All right, plus x to the 4th over 3 factorial. And then we're going to write the general term. So the denominator would still be just n factorial. The numerator would be x to the what? Perfect. You guys got it. Nice job. All right, for this one, you're going to look at your cosine of x power series on here, and 2 transformations have happened. All right, so watch me point to this. The first one is that we're going to subtract 1. So all that is going to happen is, do you see that 1 that's in front? That's gone. We subtracted it. Cool? That's it. And then you're going to take every term and divide it by, bless you, x, okay? So your first term is actually going to be negative. So it's a little bit different this time. We're starting with a negative term. Remember to divide it by x, though. So it's going to be negative just x over 2 factorial. Plus, all right, so now we're on this one. X to the 3rd, good, over 4 factorial. Nice. Minus x to the 5th over 6 factorial. Now we ran out of what's written on here, but we need to do one more because it says the first 4 non-zero terms and the 1 went away. So we need another one. So you got to be able to continue the pattern here. So it's going to be plus x to the 7th over, cool. And now we're going to do the general term. I would take care of the fact that it alternates first. Instead of -1 to the n, it's going to be to the power n plus 1. Why is that? The first one's negative instead of the first one being positive. Okay. And then I would do the denominator next for the factorial. If you plug in 0, you want to get 2. If you plug in 1, you want to get 4. If you plug in 2, you want to get 6, and so on and so forth. So think about it. This is the hard part. I think it might be 2. Is it 2n plus 2? Is that going to work? Yes, 2n plus 2. And then up here, do you notice how those numbers are just 1 off from the denominator? So instead of 2n plus 2, it's going to be 2n plus 1. Cool. Number 9 is kind of a trick question. Oh, go ahead. No, so if you plug in 0, 0 plus 1 is 1. That's going to make that term negative. If you plug in 1, 1 plus 1 is 2. An even power is going to make that term positive. Oh, well, yeah, I mean, if you want to think about like this being in parentheses, like order of operations, like PEMDAS, that's what happens first. I can't hear you because people are talking. Go ahead. You're subtracting 1 from the entire series. So you got this whole thing, and you take off 1. So that 1 went away. We just took the whole series and subtracted 1. Don't overthink it. All right, number 9 is a little bit of a trick question. Throw this aside. It's not that one of those. All right. I want you to look at it and think about what from the last unit we did it sort of reminds you of. And if no one comes up with it, that's fine. I'm going to tell you, obviously. I'm your teacher. It's my job. But I just want to throw it out there and see. It's what? It's geometric. I am so impressed. All right. What is A? There's only so many numbers in the problem. Good job. 2. And R is x squared. It's A over 1 minus R. If you feel like you forgot that, write it off to the side. A over 1 minus R is your pattern for your geometric series. So if we write this out, our first term is 2, and we only have to do the first 4. And then you just keep multiplying by x squared. So 2 times x squared is 2x squared. And then you're going to multiply that by x squared. So 2x to the, good, perfect. And then one more would be 2x to the 6th. Nice. You have to just notice that. I know that's like, I know you hate that answer. I know it's such a crap answer. But if you see a number over 1 plus or minus something. So this is your first term is 2. And then this is your ratio. You just keep multiplying by x squared. So I multiplied that by x squared, multiplied that by x squared, multiplied that by x squared. Okay. No. We're going to write the general term. So let's give it a shot. It's going to be 2x to the what? And if you want to write your 0, 1, 2, 3 out. Perfect. I have to write 0, 1, 2. Is anybody else on board with that? Or are you all smarter than me and you can do it without writing it? I have to write it so that I can see like what's going on. All right, these ones, what did I change about the directions? It just says write the first 4. Are we going to write a general term for these? No, these ones are a little bit more complicated. We're not going to have a general term for it. All right, this one, we are adding sine plus e. So pull out your handy little cheat sheet here. And I think they're right next to each other. They are, which is super convenient. All right. So we're going to add these together, but we only need to go to the 4th one. Okay. So we're going to start with 1 plus, it's actually 2x. Why would it be 2x? Do you see how they both have an x? We're adding them together. I just want to make sure that's sinking. Is everybody on board? We're taking this one and we're adding it to this one. So 2x. Plus, now do we have an x squared term? That's where we would want to look next. In e to the x or sine of x, is there an x squared term somewhere in there? Because we want to go in order. Yes, it's x squared over 2 factorial. Now this is interesting when this happens. Do you see an x to the 3rd term? They both have it, and look it. This one is plus x cubed over 3 factorial, and this one is minus x cubed over 3 factorial. So what happened? Yeah, those cancel out. I know. I actually hate when that happens, and you're going to hate it even more in the next problem. I'm just a heads up, all right? So we did to the 0, to the 1st, to the 2nd, to the 3rd canceled out. Is there anything to the 4th in either of these? There is. It's in the E one. It's just this doesn't have it written out far enough, but it would be what? What would be the next term? 4th over 4 factorial. And then we get to stop because we went far enough. We got the first 4 terms. Do you see how we just added them together, though? It's more algebra than anything else. Now, this one, we're going to take them and we are going to multiply. Here is the thing. I don't know how far out I'm going to have to go because things might cancel. So you want to go a little further than you think you might need to. This one went out to the 4th. I would suggest we go out to the 5th power because I don't know what's going to cancel. If you want to be extra sure, go out to the 6th power. Do you understand what I'm saying? Like, you don't know what's going to cancel until you get in the trenches and start doing this. So just as a heads up, it's going to be about yay long. Pretend you're back in algebra 2. Not really calculus. We're just sort of multiplying things together, right? So what I would do, this is me, stay organized. I would take this 1 and distribute it through sine of x until I get to the 5th power. I'm going to go out to the 5th power. I think that should be far enough. So if I take 1, I'll write on my paper, and I'm going to distribute it to everything there. Then I would just get x minus x cubed over 3 factorial plus x to the 5th over 5 factorial. And I'm going to stop there. I don't think we would need to go out to the 7th. Then I would take this x and distribute it to everything. Well, not everything. I'm only going to go out to the 5th power. I don't think we'll need to go beyond that. I think you'll see what I'm. Can you wait till I finish this? Because I think you'll see it if you just give it a second. All right, if we distribute x, what are we going to get? X squared minus x to the 4th over 3 factorial. And then if I distributed it here, I would get x to the 6th. I'm only going to go out to 5. I think 5 will be enough. All right. Now I'm going to distribute this term to everything. I know, I don't like this problem either, but I saw some in the question bank, which means it can show up. So I'm trying to cover all the bases. You can complain about me as much as you want, but I'm going to send you in there ready. All right. So if you distribute it to this first term, that's going to be x cubed over 2 factorial. And if you distribute it here, it would be minus x to the 5th over 3 factorial. And I'm going to stop at the 5th. I think 5 is going to be far enough. Ready? You having fun yet? Are we going to take this and distribute it? Probably not very far, though. If you distribute this x cubed over 3 factorial to the first term, it would be x to the 4th. Okay. Over 3 factorial. If I distribute here, what's going to happen? Well, I'm multiplying, but it would go to what power if I multiply these together? 6. 3 plus 3 is 6, and I'm only going to the 5th. So we need to review our algebra skills here. All right. Now, what would be the next term here? It's not written in, but I need it. 4th over 4 factorial. I think we're only going to need to distribute that to the first one. What would that give us? Yeah, x to the 5th over 4 factorial. And then I think we're good. I'm going to set this aside. We're going to combine like terms, see what we get. Does anything go with the just plain x? No. Okay, so just x. I'm going to cross them off as I go because the problem makes me angry and it's satisfying to cross things out. All right, and then do I see an x squared? Yes, does anything go with it? No. All right, so just plus x squared. Now we're x to the 3rd. I have a negative x to the 3rd. What is 3 factorial? Because I think we're going to need to, yeah, that one's 6. And then I have another one here, which that's just 2. All right, so if I combine those together, it's 1/2 minus a 6th. 1/2 would be 3/6 minus 1/6 would be 2/6, which is a 1/3. Make those go away. All right, do I see x to the 4th? Yes, I have this one and I have this one. But what's going to happen? Those cancel. And that's why I went to the 5th, to just make sure I went far enough. It's very difficult to go, oh no, I didn't go far enough and then go back. That's like, you'd almost, hate to say it, but you'd almost give up at that point. Like, just make sure you go far enough. Now this would be 1 over, does anyone know 5 factorial? You might want to know up through 5. 3 factorial is 6. 4 factorial is 24. Can I just put that in the calculator? Is that okay? What would it be? 1/120th plus what? What's the next one? Minus 1/6, and then plus 1/24th. Sorry, I'm going to a calculator for that. That is negative 7/60th. So negative 7/60th x to the 5th. Good, we survived it. And I showed you one. It can show up. You just have to make sure you go far enough. If you're multiplying, go a couple terms further than you think you need to. All right, last one. We're going to use a power series to approximate this with an error less than, what would that be as a fraction? 0.01. It would be 1/100th. So we're going to go, again, a little further than we think we need to so that we can, make sure we get our error smaller than 1/100th. This is E. You're going to find E on here. Everywhere there's an X, you're going to replace it with negative X squared. Good, we're still on board. I didn't put you all to sleep, all right? So find E to the X. Everywhere you see an X, we're going to replace it with negative X squared. So that's going to be 1. So it starts with 1. And then what? Yep, minus X squared. Now, it will still be plus for this one. If you plug in negative X squared and square it, when you square something, it's going to turn positive. So it'll be X to the 4th over 2 factorial. I'm going to actually choose to write it that way because we're about ready to do an antiderivative, and I think it'll be easier if it's written that way. All right, next one will be negative. What do you think? If we plug in negative X squared, it'll be X to the 6th, and then 3 factorial is 6. All right, now let's go one more. I think we're going to need to go one further. If you plug in negative X squared to the 4th would be X to the, I wrote it wrong. What will our power be? X squared to the 4th. Good. 2 times 4 is 8. And then 4 factorial is 24. I think that's going to be far enough. Just go further than you think you need to. Now, we're going to do an antiderivative. It's been kind of a while since we've done a regular old integral. What's your antiderivative of just 1? Good. Cool. You haven't lost your skills. All right. Minus 1/3 x cubed plus why would it be 10? It'd be 1/5, but there's already a 2 there. 2 times 5 is 10 is what we did. All right, minus, what do you think about this one? 1/42. Good. X to the 7th. And then one more. Now, it would be X to the 9th. 24 times 9. What is 24 times 9? 216. There we go. Had to use my brain there. Such that 0 to 1. The good news is if you plug in 0, they're all going to be 0. So we really just need to plug in 1. It's going to be 1 minus 1/3 plus 1/10 minus 1/42 plus, sorry. I got so excited about multiplying 24 times 9 in my head, I forgot to make it a fraction. All right, plus 1/216. We did go far enough, go us. Is 1/216 smaller than 1/100? Do you remember your alternating series error bound? The error is smaller than the next term. So we went far enough, and our answer is whatever these ones added together is. Do I need to put that in a calculator, or do you understand that would be some kind of decimal? Anyway, this part is your answer because the next term, do you remember it being the next one? Okay, the next one is smaller than 1/100. Can you imagine if you didn't go far enough and then you had to stop what you were doing and go back and find, like, how far do I need to go? Just always go a few terms further than you think you have to. Okay? Because if we stopped here, is 1/42 smaller than 1/100th? No. And you would be like, oh no, I didn't go far enough. All right. So just The rule of thumb is go further than you think you need to. Okay.